Hey everyone, this is Mrs. Shin again. Today let's go over logarithms. Okay, so this is the rule for logarithm. Okay, this is a power form, exponent form, and this is logarithm form. Okay, logarithm is another way of looking at exponentials. So that's what we have done many times in the past years, right? Okay. So this is called power or exponent, okay? And therefore this is called exponent form. And this one, this is called logarithm form. Okay, then let's think about how it's related, exponential form and logarithm form. Okay, so here, these are the examples of exponent forms. A to the power of b equals c, right? Obviously, anything to the power of 0 is 1. 2 to the power of 1 is itself, which is 2. 2 to the power of 2, 4, and obviously 8. So basically, it means it's growing by 2 1 times, which is 2. Okay, 2 to the power of 2 means 2 times 2, so it's growing by 2 twice, and the result is 4. 2 times 2 times 2 is 8, so it's growing by 2 3 times, which the result is 8. Okay, so in another means, I can rewrite 2 as growth rate, 3 as number of times, and obviously 8 as results. Okay, so now I'm going to use the last example of this one. I'm going to use the rule to transform the exponent form into logarithm form. Okay, so I wrote log, and log a, where do I have a? Yep, it's a base over here. So base is 2. So I'm going to write small letter 2 over here, down below. Alright, C, which was the result. Okay, so this time it's 8 beside, equals B, and B is the number of times the power exponent at the top. So I'm going to write that equals 3. Okay, so if we revisit, okay, what 2 stands for, it was the growth rate, right? So that means it's how fast you're growing. And 8 over here was a result. That means how big you'll end up. So that's how fast you're growing, and then you know how big you'll end up, right? So therefore it's asking, right? How long did it take from the growth rate to get to the end point, which is 8? So obviously, how long did it take? 3 times 2 times 2 times 2, which is 8, right? So yes, this can be linked back to exponent form that we have done over here according to the rule. So easily we can change this exponent form into logarithm form. Alright, so let's have a go at, for example, changing this one, the second one. Okay, if we just follow the rules, A, B, C, it can be written as like this. Okay, again, to understand how fast you're growing is 2, the end point is 2. Oh, it's the same. So how many times? It's just 1 itself, right? Okay. So I want you to learn this rule, okay, and make sure you know how to apply it. Okay, and if you want to know how to read this one, the logarithm form, the base A, it was the base, right? So log base A of C equals B. Okay, so this is how you read the log form. Okay, so we have done examples of these simple ones, changing back to logarithm forms. Now have a go at the fraction one. Would it be the same? Yeah, because this is 9 is A, B is a half, and C is 3. So you just apply it to this form. Have a go. You all got this answer? Yeah? Okay. Then have a go at doing this one. Okay, this time b value is negative value. Okay, but that's still the same. Yep, like this. And it's very easy if you just follow the formula. Okay, you're doing good. We're halfway there. So we have 3 more rules to learn. And the first thing is adding. When you add the log of the same base, log A plus log B, you multiply those two together, okay, and you get A and B multiplied. Okay, so if you have something like this, log 3 plus log 5 plus log 6, what are you going to do? Okay, it's all the same base, so therefore I'm going to multiply 3 times 5 times 6. Log 90. Okay, and thinking backwards, obviously if I have log AB, then you should be able to think that it's log A plus log B. Like this example, just going backwards, right? Okay, so the second rule for the logarithm, if you're minusing them with the same base, log A minus log B, then we divide the top and the first one and the second one, so therefore A over B. Okay, so this is pretty easy. Log 20 minus log 4, okay, same base, so therefore what would it be? I'm dividing 20 and 4. Okay, and you should end up having log 5. Okay, so here's a tip for you. Many people think this and this are equivalent, but however it's not. This one is log 15 minus log 3, whereas this one is log 15 divided by log 3. So it's a different thing. So please don't get confused when to divide and when to put it in division inside the bracket. Okay, so this is the very last rule that we're going to cover today. So if you have a look at this one, log a to the power of n, and on the left hand side it's n times log a. Right, so if I have a power, then I can bring this down in front and multiply it. So n times log a. Vice versa, if I have a value multiplied in front of log, then I can pull it back as a power for a. Okay, so for this one, right, I have 9 to the power of a half. I can pull this one down in front and I can rewrite it as like this. And people, for example, like this one, you can simplify it. Okay, so 9 to the power of a half is, what is it? Square root of 9 is 3. So therefore, you can also rewrite this as log 3. You don't have to be, it doesn't have to be in the power form. But if there is any power, then here is a rule to follow. You can pull the power down in front. Okay, so today we learned logarithm rules. I hope it was okay. So now have a go at doing some questions from the book and practice the skills. I'll see you next time. Bye bye.